Okay, hello everybody, what's going on? This is Mohammed. Welcome to another video. In this video, I'm going to teach you how to solve for this indefinite integral. So we have here the integral of 1 divided by cosine squared plus tangent squared dx. So how can we solve for this integral? Okay, so first of all, I will start by rewriting cosine as 1 minus sine squared and tangent as secant squared minus 1, and let's see what happens. Okay, so this is going to be equal to the integral of 1 divided by cosine can be rewritten as 1 minus sine squared of x, and tangent squared is secant squared of x minus 1, and that is dx. And we can notice here, guys, that 1 is going to get cancelled with 1 here, okay? So what we're going to be left out with is secant squared minus sine squared, okay? So this is going to be equal to the integral of 1 divided by secant squared of x minus sine squared of x dx. Now, I will multiply both the numerator and the denominator by cosine squared. Okay, so that is going to give me a cosine squared in the numerator of x, and secant squared is going to become 1 minus sine squared cosine squared. Okay, sine squared of x, cosine squared of x, and of course dx here. Now we can notice that sine squared, cosine squared, sine squared, cosine squared can be rewritten in terms of sine twice the angle as 1/4 sine squared twice the angle x. Okay, so this is going to be this can be rewritten as, okay, in the numerator we have cosine squared of x, and this is 1 minus 1/4 sine squared of twice x dx. Why? Because sine 2x is 2 sine x cosine x. If you squared that, that's going to give you 4 sine squared of x cosine squared of x divided by 4. So that's going to give us sine squared cosine squared. Okay. Okay, so now what we're going to do next is to multiply both the numerator and the denominator by 4 so that we get rid of the 1/4 in the denominator. So that's going to give us 4 cosine squared of x divided by 4 minus sine squared of twice x, sorry. And of course, dx. Okay, and then we're gonna rewrite cosine as using twice the formula of cosine twice the angle. So this is gonna be equal to the integral of, okay, cosine squared is 1 plus cosine twice the angle, 2x, divided by 2. So 4 divided by 2, that's gonna give us 2 multiplied by twice cosine 2x divided by the same exact denominator, which is 4 minus sine squared 2x dx, of course. And then we can split both this integral into two separate integrals. Okay, so that's what we're gonna do. That would simplify things. So this is gonna be equal to 2 divided by 4 minus sine squared twice x dx, and plus the second integral is going to be twice cosine 2x divided by 4 minus sine twice 2x, okay, dx. Okay, and for the first integral, what we can do here, we can rewrite sine squared or we can divide both, we can divide both the numerator and the denominator by cosine squared. So that's going to give us twice secant squared twice x, and 4 is going to become 4 secant squared also twice x, because we divide that by cosine squared, and sine squared divided by cosine squared, that's going to give us tangent squared. So minus tangent squared of 2x, of course, dx, and the other integral would we can go ahead and solve it. By the way, the second integral, we can benefit from the idea that the derivative of sine twice x is in the numerator. So basically this can be, with a simple u substitution, this is equal to the integral of 1 over 4 minus u squared du, which basically is equal to 1 over twice the constant, the squared constant, which is 2 here. Okay, so 2 multiplied by 2, that's 1/4. Okay, the natural logarithm of the absolute value of the squared quantity, which is basically sine 2x, plus the constant, the squared constant, which is 2. So so it's going to be 2 plus sine twice x divided by 2 minus sine twice x, and I will close the absolute value. Let me put this here, and of course plus c. So we're done actually with the second integral. Now we're left with the first integral. Okay, so what we can do here, we can rewrite the secant squared as tangent, okay, as in terms of tangent, which is tangent plus 1. So that is going to be equal to the integral of twice secant squared twice x for tangent squared minus tangent squared. So we're going to be left out with 3 tangent squared. So 3 tangent squared twice x plus 4, okay, plus 4, because plus 1 multiplied by 4, that's going to give us plus 4 here, dx, and everything else is going to stay exactly the same. So what I'm going to do here, I'm just going to copy this result and put it down as well. So copy, and so I'll put it here, paste. Okay, exactly. Okay, so nothing is going to change, okay, with the second term. Okay, now the first integral. Okay, we can notice here that that the derivative of so first of all, let's divide by both the numerator and the denominator by we can go ahead and divide the numerator and the denominator by 4, but let's keep it like that. Now we can notice, okay, that the squared quantity in the denominator is basically the square root of 3 tangent to x all squared plus 2 squared. Now, if we have the derivative of the square root of 3 tangent squared, which is basically twice the square root of 3 secant squared 2x, so we're missing the square root of 3 in the numerator. So basically, we need to divide by the square root of 3. Okay, and of course we need to divide by the squared constant, which is 2. So that's going to give us 2, and that's going to give us tangent inverse of the squared quantity, which is basically the square root of 3 tangent of 2x, basically divided by the squared constant, which is 2. So that is basically the first, the answer for the first integral. Okay, of course we can go ahead and do u substitution, but I would prefer to do it right away like this. That would save time and space here. And the second part is exactly the same. So what I'm gonna do here, I'm gonna just paste the second term, but I need to add a plus sign here. And that is basically the answer to this problem. Okay. Now you can notice, guys, that the second term can be rewritten. The second term can be rewritten using the inverse hyperbolic tangent. Yes, but of course you guys know that the inverse hyperbolic tangent can be rewritten in terms of the natural logarithm, which is basically the natural logarithm of x plus 1 over x minus 1. So we're gonna get finally to this final expression here. So that is basically the final expression or the final answer to this problem. I will just put that into a box and try and highlight it in like a yellow color. Okay, so that is the final answer. I hope you guys have enjoyed the solution. If you liked the solution, please hit like, and don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.